All right, this is the exciting section. This is the Rayleigh criterion, R-A-Y-L-E-I-G-H. Right, so if we're looking at a star and a star, right, and the question is, can we, with the aperture of our telescope, can we discern this, right? That's our aperture of our telescope. So a big telescope lets us discern a small angle, right? Okay. And then this is the wavelength of light. So short wavelength of light is good to get a small angle. A big aperture is good, right? And then the 1.22 basically puts the diffraction pattern, right? So you've got bright, dark, right? The bright spot of the second star is on the dark spot of the second thing's diffraction pattern. Okay, that's what it does, and you can look at the video for that. I explain it a whole lot better there, right? But just understand, big aperture gives you a small angle of resolution. This is the angle that we can resolve, right? Okay. Remember that angle is also just S divided by R, where this is R and this is, they'll give you an S like that, right? Okay. What else to say about this? What's interesting is that in a lot of things, they create false apertures, right? So like, for example, that whole Big Bang image that they took, they used several telescopes spread out across the Earth and put the light together. They observed the same spot in the sky simultaneously, and they used that kind of as a baseline. Okay, and there's ways to make a telescope seem like it's bigger, right? The bigger the telescope, the better the resolution. Okay, and then this is for diffraction grating, right? We're trying to do, let's say we got a spectral line here and a spectral line there, and there's one really close to it, right? That's that little gap there. That's our difference in wavelength, right? And then this is the wavelength of light. That's the order, as in first order, second order in the diffraction pattern, right? And then this is the number of slits illuminated. Number of slits illuminated, right? This is the difference in wavelength that can be discerned, right? So basically, to get a very sharp image, you want actually a whole lot of lines illuminated, right? And then the resolvency, this is what the R is, right? The resolvency is let's say your resolvency is 1,000. That means that you can resolve one part in 1,000, because this would be 1,000 nanometers, and that would be 1 nanometer, for example. Okay. Anyway, yeah, take a look at the example problems for that.